Hey guys, in this tutorial we're going to take a look at animating geometry in Grasshopper. In fact, what we're going to be creating is an animation that looks like this. Sort of like a tunnel that appears as if from nowhere. So as we adjust this slider, it's going to slowly pop open and create this completely closed off tunnel in the end. Alright, so let's break it down. So I'm going to start with a curve. Brought that curve into Grasshopper, and then we're going to rebuild it, and I can also hide it now, and I'll preview this off, and I'm just going to change my rebuild settings. I want this to be relatively simple. You know what, 5's probably good enough for me. And what we're going to do is we're going to pipe this, and we'll increase our radius up to 100, and somewhere around there is good for me. And we're going to change the end cap style from none to round. Alright, now what we're going to do is we're going to deconstruct this prep, and we're going to list item out the faces, and there's going to be 3 faces. The first one's going to be our middle face, and then the item 1 and 2 are going to be our end caps. So what we want to do is a surface divide. There it is. And so I'm going to start by dividing this one, and I'm going to throw down 2 sliders, each with a maximum of 12 divisions, and we'll plug these both in. Okay, so around the axis of this pipe I'm going to go with 8 divisions, and then along the length I'm going to go with 9's good for me. And then we're going to duplicate this, and we're going to one by one plug in our other 2 surfaces. And so now you're going to see that we have a slight error in the way that this surface division is dealt with, in that if I were to change this number here for my surface, for my central part of the pipe, it's changing the item count along the length, whereas for my end caps it's changing the length of the item count along the axis. So what we need to do is we need to change these around. So this for my end caps, this number 8 is going to control my U direction, and we're going to create another slider for my V. So that way we're getting a uniform number of caps around this side, and then this end cap are the number of length caps, the number of length divisions is also controllable by this slider, and I think 3 is good for me. So now we're going to need to sort of rematch our data structure. So in order to do that, I'm going to grab a path mapper. And also what I'm going to want to do is, you'll notice this list item brought these surfaces in as 0, 1, and then 2. So I'm going to remap that to 0, 1, 2. And so I'm going to start by simplifying all of these outputs. And then we're going to create null mapping. So this first one is probably the way that I want to keep the data structure. So I'm going to change this from A to 1. 1 and then A, because we still want to keep that hierarchy that we have. Alright, for our next one, we'll see what we have. If I just pull out a list item, whoops. and in fact I'll just use index 1. Okay, so that's giving me axis divisions, whereas what I want is length divisions. So I'm going to flip this around using, actually, whoops, oh yeah, I'm doing the right one. So AI, and this is going to change to 0i inside the curly braces. And so that'll give us the division along this length, which is what we want. And then this one, we'll see what's going on there as well. Chances are it'll be the exact same sort of deal. Cool, so that fixes that for now. The other thing I'm going to need to correct is on this, what am I saying? On this central section, we're going to have double up points. So I need to get rid of those. So I'm going to try a cull index over here. Let me just preview these points off and see what I get if I just type 0. Where is it culled out? Oh, that's right. So what it's actually going to be doing is going to be culling out a row of points along here, because we're going to have one set of points on top of another. So we know that, in fact, just to prove that to you, I'm just going to change this slider up a little bit. And so if I were to cull out index 1, you can see this entire edge disappears. And if I were to cull out the last index, which is index 8, you can see we still have this line of points still existing, because the first and the last index are exactly the same. So we'll deal with that in a minute. So what I'm going to need to do is I'm going to need to flip this matrix, and then I'm going to put that through my cull index. I'm going to get rid of this. I'm going to set multiple integers to 0 and -1, and so that's gotten rid of those edges I didn't want. And then I'm going to need to plug this back in here. Simplify this. We can get rid of that simplification. And we're also going to need to flip the matrix around. So AI becomes 1i. There we go. Now I'll just move this along a little bit. Now this next one, okay. We won't be able to tell what exactly the problem is until we take it a step further. So we're going to combine all the points. Let's see, so this one needs to be 2i. And so now we can join these all up. 0, 1, and 2. And then I can preview these off. I can grab, let me just check that we've got 9 points in every branch. Yes, we do. So now I can do a surface from points. I'm also going to grab a tree statistics component, because I want to know how many lists I have. So I'm also going to grab a list length component and plug that in. And this is going to be my U, and then my points are going to feed in here. And when I flatten this, alright, now we can turn our pipe off. And you can see we get a bit of an error over here. So this tells me that for cap 0, I'm probably going to need to flip the, what's that going to be? Let's try the path count. So inside my index number, I'm going to say path underscore count. You can see I'm pulling this out from here. Path count minus a, and we get an error because now there's 10 points, because we need to go path count minus a minus 1. Alright, so that fixes that side. And then on this side, we're probably going to need to flip the path count and the index and the item index count. So I'm going to put a bracket in here, and we're going to go item underscore count minus I minus 1, and then outside we're going to do the same thing we did before, path count minus a minus 1, and then close that bracket off, and there we go. That's fixed any sort of issues that we had. We could have also done this with a flip matrix and then reversing the list, and we would have had to reverse the list in here. Actually, you know what, why don't I just show you? So we could have just reversed this list and then flip the matrix around, and then we would have probably needed to do another list reverse here. Oh, not quite. Oh yeah, so now you can see we get a mismatch in our data structure, so we would have needed to take this and change it to, okay, let me just create null mapping, and we'll go 2a, and then we'll just reconnect that. So there you go, you can see that's done the exact same thing, but I might as well be showing you the usefulness of the path mapper. It gets rid of, what was that, 4 components there? Alright, so now we've done that. The next issue we have is that if I were to bake out this surface now, just so that we can see what's going on with it. Actually, that's a good thing to point out. I don't know if I've done this before. If you're ever in a Rhino command over here and you try to bake out from Grasshopper, it's not going to let you. You need to cancel that, and because the bake operation is sort of thwarted by anything you're trying to do in Rhino, and then you can bake this piece of geometry. Okay, so the next issue we have is, you can see we've got a bit of a seam along the edge here, and the reason we're getting that is just because when we did this surface division and extracted all these points are very close to each other, but not exactly lying on top of each other, meaning they're not going to align properly, so we're not going to get a properly closed surface. So what I'm going to do is I'm going to put a cull index over here, and I'm going to set my index, I can do it to either 0 or -1, and then when I replug all this in, we're going to have a sort of open surface. You can see that edge is open, which is not ideal. So what I'm going to do is I'm also going to take this opportunity to shift the list around, because I'm not happy with where my seam is at the moment. I want my seam to be at the bottom of this pipe. So I'm going to shift it with this slider, and then I'm going to put down a repeat data, and we're going to grab the list length from this list of points over here and then plug it in, or alternatively we could take 8 and create an expression which would just be x plus 1 and instead of doing this list length we could just plug that in there. And so now we're going to link all these inputs back in and then remake that connection, and then preview these off, and we're going to check our surface. Okay, so you can see our seam is now it's now right at the top, and I want it to be right at the bottom. So now let's bake this out and see what we're getting. Okay, so it looks like we're still getting that really, really rigid seam. Let me just see if I can fix this. There we go. So I just inverted the boolean for interpolate samples, and that's given us a nice smooth edge there as well. Alright, cool. So now we've got this surface, and now we get into the actual animation part. Well, almost. We're very close. This was all just set up for our geometry. So the next thing we're going to do is an ISO trim. And I need to create a domain, or some domains for this. So what I'm going to do is I'm going to quickly reparameterize this surface. I'm going to throw down a range over here. And I'm going to change my maximum number of steps to 20. And then I'm going to use a component called consecutive domains. So this is a really good component. What it does is it looks at the numbers you plug in, and actually if I just set this to 10 so it's a bit easier to see what's going on, it's basically going to create consecutive domains from this, but you have two different options for how it can do that. It can either add the result or add the numbers to the previous ones in the list, which means that your number or your sort of final domain will be the cumulative sum of all these numbers, or you could invert the boolean so that the domains are not additive, which is what we want in this case. And so in order to use the subsurface, I'm going to also put down a construct domain squared, and we have our U domain. So you can see I've now split this surface up into 10 parts. I can do as many as I want, and now we need to create something for the V domain. And so what I'm going to do here is I'm going to start, actually I'm firstly going to cull from this range my first integer, and then what I'm going to do is I'm going to create an expression which is going to be y to the, oh, it could be x to the y or y to the x, and so this is going to be my the value I'm raising, and then this slider is going to be the number being raised. And so what this is going to do, don't know how well you'll be able to tell this. Maybe if I pull out the graph mapper we can see this a bit better. So I'm going to just create a Bezier curve, and excuse me. So you can see we get this really useful sort of bunching of values, and they're always going to remain between 0 and 1. So this is just a really neat way to sort of shift your data, or sort of load it one way or the other, so that it's either bottom heavy or top heavy, or something in between. And so what we can do is we can use this for our V domain. So what I'm going to do is, at the moment this is spitting out numbers from 0 to 1, so if I were to just do this now and animate through the slider, you'll see it's slowly sort of creating this wraparound to close off, or to create sort of closed sections. And that's almost what I want, except I want it to sort of spawn from this center line, and actually I was just about to do hand actions there. I want it to sort of spawn from the center line and then create a closed seam at the top. So what I'm going to do is I'm going to have to construct two domains. And I'm also going to need to multiply this result over here by 0.5. Alternatively, you could just divide by 2. And so this is going to be my my b value over here. And then on this side, I need an expression which is going to be 1 minus x. And this is going to be the start of my second domain. And so now I'm going to graph these two inputs, or outputs, and I'm going to graph this input, and then I'm going to plug these in. And so what you should now see is when I adjust this slider, I'm going to sort of slowly close off this shape. Now the reason I brought the graph mapper in is that we can do a really cool thing with this when we're animating, and we can sort of this is almost like keyframing in a way. We can change the interpolation bias so that the animation speeds up in the middle and slows down at either side. So if I just shift through this slider very slowly, you can see that we get that really quick jump right in the middle, and that occurs for each and every one of these sections, and then it closes off really slowly again. And okay, so that's the first method I wanted to show you. The second method is going to be a little bit more complicated, only a little. What we're going to do, actually I'll just make a copy of all of this, and let's see, I'll move this over. I probably don't need these at the moment. We're going to create a string of expressions over here. So my first expression, actually first thing I'm going to do is I'm going to create a domain from 0 to whatever number, and then on this side I'm going to create an expression which is going to be let's see, 1 minus x plus y. So it's going to be 1 minus x plus y, so this should give us the start of our domain and the end of our domain. And so then the next expression I'm going to create is going to test whether this slider value is inside this domain. And so the way we're going to do that is we're going to go y minus z inside brackets over y minus x. I'll explain this in a sec. So my y value is going to be my maximum. Whoops. My y value is my maximum. My x value is my minimum. And my z value is my parameter. Okay. And then the other thing I need to do is I need to say 1 minus this expression. And so what this is basically going to tell me is that anytime this number is greater than 1, or greater than or equal to 1, the domain is complete, and anytime it's less than 1, So those two numbers which are less than 0, sorry, it's completely outside the domain. So I need to add two more expressions after this. I can get rid of this y and z. First one is going to be two if statements. So if x is less than, if x is less than 0, replace it with 0, otherwise x. So once again, if x is less than 0, that's our condition, then return 0. If it's not less than 0, return x. And then we'll daisy chain one more expression, which is going to be the opposite. So if x is greater than 1, return 1, otherwise return x. Okay, so now we should be able to plug this in here. And if I just drag my slider over here, you should notice what we're going to get this time is we're going to get completely uniform divisions. And they're just slowly going to shift up and down this this graph. And so this, let me just make sure I've done this right when I plug it in here. I have, whoops, plugged that into the wrong thing. This is meant to go into my domain. And it looks like we've done something else slightly wrong. My u value, yes, so my u value needs to remain the same, so it needs to come from this range over here. Alright, there we go. So now when I change this slider, we also now have sort of influence over how many spans appear in front of our, like you could imagine a person sort of walking through here and these platforms slowly appearing in front of them. So the higher this number, the less the range of influence. The lower the number, the wider the range of influence. So if I were to keep this at, say, somewhere around 0.6 and then change this slider, you'll see the result is this very shallow region of influence where a person walking through would only have sort of 2 or 3 platforms opening up in front of them, which is just a slight variation of this over here where everything sort of opens at once, but the ones further down the line are just a bit slower. If we run through this slider again, you'll see that's the case. Now there was one other thing I probably wanted to show you. Let me see if I can remember what it was. Yes. So just spotted that right on this last one we're getting a double up of our geometry, and that's because we're passing in 10 surfaces over here. Let's see, where is it? 10 U domains and 11 V domains. So all I need to do is just add an expression in here, which is going to be x minus 1, and that's this value here. And there we go. That's the basics of the animation done in Grasshopper. Now, if you've ever right-clicked on your slider and saw there's a little animate function here and wondered, wonder what that does. Well, we're about to find out. if I click it, this opens up a little window which basically allows me to output an animation. So I can choose which viewport I wanted to export. I need to set a location, so I'm just going to go into my libraries, to my pictures, and make a new folder called, let's go with tunnel animation, and then click OK. One thing I've always found is that when you're exporting this file, your bitmap, or saving it as a bitmap, is not always the best idea, especially if you wanted to put it into After Effects or even Photoshop or something. For some reason, the bitmap is not very friendly, so I always save mine as PNGs. And then you can set the resolution here, you can set the frame count, so I'll just set it to 100, and then I can just check my view over here. Happy with that. I'll click OK, and then it's going to export out this animation. And I'll go into my pictures folder, go into tunnel animation, and we can now see we've successfully exported this animation. Just a few other sort of housekeeping things. If I do go back to, oh, it looks like I closed it. Pictures, tunnel animation. Just if you, when you do create these animations, it is going to give you your world axis icon and your grid. If you did want, you could remove those in the options. So in grid, you turn off show grid lines, show grid axes, and show world axes icon. You could also go into appearance, and under colors you could change your background color. And key thing to note though, if you are in rendered view in Rhino, you need to check, or you either need to go to any other view like wireframe or shaded, and this background color will change over here. Otherwise, if you're in rendered view, you need to go to view down the bottom, display modes, rendered, and change your background to solid color and black. Alright, I don't want to do that, so that's okay. Alright, so here, that was a brief look at animating in Grasshopper. I hope you enjoyed it.